Hi folks, me again. Just want to clarify something about calculating the price elasticity of demand, which is something you're going to have to do on the first exam. I would like you folks to to use the midpoint formula. So what do we mean by the midpoint formula? By the way, this is this is from lecture 5, slides 4, 5, and 6 kind of go over this. So what I'm going to do is do the board work that I would normally do if this were a regular face-to-face class. So let's start off by thinking about what the price elasticity of demand is. We've got a downward sloping demand curve. We've got price on the y-axis. We've got the quantity, which we call Q, on the x-axis. And what we're trying to do when we calculate the price elasticity of demand is figure out how sensitive buyers are to a change in price. So what we need to do is we need to take 2 points along our demand curve. We'll call this A and B, and we're going to ask ourselves, if we change the price, either we raise the price from B to A or lower it from A to B, does that lead to a big decrease in quantity demanded or only a small decrease in quantity demanded? So at A, we're going to say that PA is the price and QA is the quantity. If we're over here at point B, then we're going to say that P underscore B is the price and QB is the quantity. When we calculate the midpoint formula, what we're doing is we're saying there's some point halfway between A and B, we'll call this M over here, and we're calculating the price elasticity of demand halfway between A and B. Now, why do I want you folks to use the midpoint formula? A couple reasons. One is, if you don't use the midpoint formula, the calculation that you come up with will depend on whether or not you start at A and go to B, or start at B and go to A. You'll get two different numbers. If you use the midpoint formula, it doesn't matter if you start at point A and go to point B, or start at B and go to point A, you'll get the same number. The second reason is that it's more precise, at least for this point right here that we're calling M the midpoint, okay? So if you calculate the price elasticity of demand using the midpoint formula, you're saying that we know, or we're relatively certain, that at this point M, this is how sensitive buyers are to a change in price. So what is the formula that we're going to use to calculate the price elasticity of demand using the midpoint formula? So what we have over here is, this is the generic formula. I'm going to write that down first. E sub D, price elasticity of demand, is equal to the percentage change. Triangle is delta, delta is change, percentage change in quantity demanded divided by the percentage change in the price. So using the midpoint formula, what we have to do is we've got to find points, plug in numbers for quantity demanded, plug in points for the price, and figure out what that might be. So what I'm going to do is I'm going to go over to the example that I'm using here, which is on slide 6. And on slide 6 we've got a graph. We've got a downward sloping demand curve, and what we're representing for point A over here has a price of 30 and a quantity of 10,000. Okay, so that's 10,000 over here. At point B over here, we've got a price of 25 and we've got a quantity of 20,000. Okay, so these are the points, these are the coordinates of the points that we're going to use when we use the midpoint formula. So when we use the midpoint formula, we're going to set up a complex fraction. A lot of you might have remembered doing complex fractions back in 6th or 7th grade. Being that it's a long time, let's go ahead and refresh our memory a little bit. A complex fraction is a fraction on top of a fraction. Now what we're going to do over here is we're going to take our quantities that we get from the x-axis of the graph and put that over here in the numerator, and then what we're going to do to set up our complex fraction in the denominator is take our prices, which we get off the y-axis, and put that into the denominator. So I'm going to go ahead and say our fraction on the top is going to be 10,000 minus 20,000 divided by 10,000 plus 20,000 divided by 2. Why are we dividing this by 2? Because we're looking for the midpoint. In other words, halfway between points A and B, the Q coordinate is going to be 15,000. I've chosen real easy numbers to work with, but we would go ahead and apply this formula if we had more complicated numbers as well. All right, so that's in the numerator portion of our complex fraction. What are we going to put in the denominator? We're going to put 30 and 25. So when we're using 10,000 for a quantity, we're going to be using 30 for a price. So we're going to have 30 minus 25 in the numerator portion of the denominator, and we're going to divide that by 30 plus 25 divided by 2. Okay, so what I want to do first is go ahead and simplify a little bit. So 10,000 minus 20,000, that's going to be minus 10,000. And we're going to divide that by 15,000, right? 10,000 plus 20,000 divided by 2 is 15,000. And then we're going to divide this by 30 minus 25, which is going to equal 5, positive 5. And then we've got 30 plus 25, which is 55, divided by 2, which is 27.5. Okay, now, a lot of you may not, if it's been a while, you may not remember how to go about solving a complex fraction. What we need to do is we need to take this fraction and invert and multiply, right? We're going to leave this portion alone, the minus 10,000 divided by 15,000, we're not going to do anything with. So I'm just going to go ahead and rewrite that, minus 10,000 over 15,000, and then we're going to multiply this by 27.5 over 5. Now, if you're using a calculator, it could very well be that if you program the numbers into your calculator correctly, you don't have to worry about going through these steps. But I would highly recommend that you go through these steps, and when you get to the very end of the problem, key in the final numbers so that you get the numbers in decimal form. Why do I say that? Because if you do the order of operation incorrectly, your calculator will calculate something, but whether or not it's the right answer, it may not be if you did the order of operation wrong. Okay, so what can we do now? Well, what we could do now before we solve is we could go ahead and simplify. So let's go ahead and do this. Minus 10,005, we can reduce that to 1, and we can reduce this to minus 2,000. Can we do any more simplification? And the answer is no, it doesn't really look that way. How do I know that? Because I've used this problem before in the past, and I know how far we can simplify. Okay, so what do we have over here? Minus 2,000 times 27.5. That's going to give us minus 55,000. That's what we have in the numerator over here, and then when we multiply across, 15,000 times 1, that's 15,000 over here. So this is where I would go ahead and use my calculator, and if you were to go ahead and divide minus 55,000 by 15,000, you'd get negative 3.7. But remember, when we calculate a price elasticity of demand, what we always want to do is take the absolute value of that number. Take the absolute value of negative 3.7, and that'll give us 3.7. So the interpretation of this is that a 1% increase in the price would lead to a 3.7% decrease in quantity demanded. If this were your product, you probably would not want to raise the price, because this indicates that the buyers of your product are very price sensitive. You change the price by a tiny little bit, say 1%, they freak out, and you lose 3.7% in the way of quantity demanded, which means your total revenue would go down. So this is the board work associated with using the midpoint formula to calculate the price elasticity of demand. As I mentioned, on the exam there will be one problem where you'll have to do that, and this is the formula that I'd like you to use. It'll make my life easier because then I can see everybody using the same formula. when I go ahead and grade it. And also, like I said, you won't have to worry about whether you start at A and go to B or start at B and go to A. You'll get the same number either way. And if you don't believe me, go ahead and try reversing these numbers. In other words, go ahead and do 20,000 minus 10,000 divided by 25 minus 30, and I promise you'll get the same number. Thanks a lot, folks.